Our next chapter or unit is on polynomials, and a lot of this unit is going to be a review from what you guys learned in Algebra 2. So today we're going to talk about what is a polynomial and how do you divide polynomials. So a polynomial function is in this form. Some basic ones would be like x cubed, x squared. They look kind of like power functions. What's important is that n has to be a non-negative integer, which means that you can't have any exponents that are negative. You also can't have any exponents that are fractions. So polynomials cannot have roots with the x. They can't have square roots or cube roots or anything like that. And they can't have any x's in the denominator. But the reason it says non-negative is because you can have 0 as an exponent. So are the following polynomial functions? It has a regular normal exponent of 4, so yes. This one is a square root, which is an exponent of 1/2, so that's no. It has to be integers, so that's like 0, 1, 2, 3. This one has an x in the denominator, so no. This one, even though it has a square root, this is just for the 3, so it's not affecting the x, and so yes, this is a polynomial. This is actually a polynomial, even though it's just 0. It's like having x to the 0 power. And this is also a polynomial for the same reason. This one is a polynomial, it's just not in standard form. And this last one is not a polynomial because you can't have an x in the denominator. This should be a review. We talked about this definition before. A degree of a polynomial is the largest power of x. The leading coefficient is the number in front of the x with the highest power. It does have to be in standard form in order to find the degree. So if you want to pause your video for a second and try to find the degree and leading coefficients of the 4 problems in your notes. In this one, the degree is 4, and the leading coefficient, which I'm going to abbreviate LC, is -3. Here, the largest power is 10, so that's the degree, and the coefficient is -1. In this one, it doesn't have any x's, so we say that the degree is 0, but the 8 counts as a leading coefficient. And in this last one, you have to imagine if it were FOILed. So remember that you have to think of x minus 1 squared as having x minus 1 times x minus 1. This isn't so bad to actually FOIL out, but we only care about the largest powers. So you can just kind of like put a ... And if you multiply all the largest values together, you'll get -2x to the 5th plus a bunch of other things. That tells us the degree is 5 and the leading coefficient is -2. This is also a review to how to find zeros. So for today, we're going to just be factoring or using quadratic formula. So to find the zeros or the x-intercepts of a polynomial, we set the equation equal to 0 and we try to factor it, or we use the quadratic formula if we need to. So for example, if I set this equal to 0, notice that they all have a common factor of x. So you can factor x out, and now you have this. Now, I would recommend you try to factor this yourself, but if you want to just watch on here, this is what the factoring would come out to. So then you just set all of your factors equal to 0, and you solve each one for x. So here you get 0, here you get -1/4, and here you get 5. In this one, when you set it equal to 0, you can start similarly. So you factor out a common factor of x, and now you're left with this. The only problem is when you try to factor this more, it doesn't factor. So what that means is you're going to need to complete the square or use quadratic formula. I'm showing here using quadratic formula, and when I simplified it, I got this. So don't forget that this x was here, so you want to set x equal to 0. That gives you one of your answers, and then this is your other answers right here. So that was our quick review of what a polynomial is. Now we're going to talk about how to divide polynomials. And there are two methods for dividing. You can use long division, which looks like this, or you can use synthetic division, which looks like this. Synthetic division is always faster, and so usually it's the preferred method, but the problem is it doesn't always work. It only works if you're dividing by x minus a. That could look like x plus 3, x minus 3, but it can't have any exponents on the x, so you couldn't have x squared, and it can't have more than 2 terms. Long division, on the other hand, it works for any 2 polynomials, so you can divide anything. This and this are examples of the same division of what it would look like in either case. So in these, I just want you to go through and say, could you use synthetic or would you have to use long division? So when you're deciding that, you're always basing it on what you're dividing by, this part. And this looks exactly like that format, x minus a. So yes, you can use synthetic division. On this one, you have to use long division because it has an exponent. In this one, it's just x plus 3, so that's actually okay. You can use synthetic division. It has 2 terms and 1 x and 1 number. On this one, it has more than 2 terms and it has a bunch of exponents. That one you definitely have to use long division. Most of the time when you divide, when you use long division or synthetic, you usually end up with a remainder. And you learned about remainders back in elementary school when you used to divide numbers. So like 23 divided by 7. So 7 goes into 23 3 times, and you used to say, oh, it has a remainder of 2. And then eventually you learned that this is equivalent to saying 3 plus 2 sevenths, because you're dividing by 7 and you had a remainder of 2 left over. Each of these things has a name. The 3 is called the quotient. That was like your answer from dividing. The 2 is the remainder. That was the part that's left over. And then the 7 is called the divisor. That's the thing that you're dividing by. So this process works exactly the same way in polynomials. It just looks longer. So if you were dividing something like this, you might get x plus 6 as your quotient. You might get 8 as the remainder, and then you put the remainder over the divisor. Again, the divisor is the thing that you're dividing by. So this is how you would write your final answer when you divide polynomials. So let me show you some examples. Here I'm going to show you an example of long division. You set up your little bar, you put this in the inside, and you put this one on the outside. When you do long division, you ask yourself, what times x makes x squared? What do you multiply by x to make x squared? So in that case, the answer would be x. You can place this x anywhere on the top. I like to try to line up the matching terms, but that doesn't matter, like how this is an x and this is an x, but that's optional. After you figure that part out, now you're going to distribute this x with everything out here. So x times x is x squared, and x times negative 3 is negative 3x. You write that underneath each of these terms. When you use long division, you subtract. And don't forget, it's like x squared minus x squared, so those are going to cancel. Your first terms will always cancel. That's the reason that we chose x to put up here. When you do 3x minus negative 3x, it's like you're adding 3x. So that comes out to 6x. Some students find it helpful to just like change the signs if you make this a negative and this a positive. Then you bring down the next term and you do that process again. What times x makes 6x? So 6. So you add 6 to the top and then you distribute the 6 to both of these. So that would be 6x minus 18. Then you subtract. Again, these always cancel. Negative 10 minus negative 18. So that's like adding 18. So that comes out to 8. Now you can't keep going because nothing times x would make 8. It would be like 8 over x or something. So you're done, which means that this thing that I've highlighted in yellow is your remainder. So when you write your answer, you put the quotient, the x plus 6, plus the remainder, 8, divided by the divisor, the thing you are dividing by, x minus 3. I would like to also show you synthetic division. So I find it much faster, but you have to remember how to set it up. So you take the coefficients of the original polynomial, so in this case m, n, q, and r, and you write them at the top here. And then I draw kind of like an L to represent like some lines just to separate things. When you're dividing by x minus a, you're going to put a here. If it were x plus a, you would put negative a. So it's always the opposite sign of this. You want to leave a space here. You're going to be writing some numbers, and then you want a space underneath here where you're also going to write numbers. So this value is what is being subtracted. These are the coefficients of the polynomial, and you need what are called placeholders, which I'll talk about in a second, which are zeros, if you're missing any of the terms. So leave a blank line, and then underneath you're also going to write some stuff. So we're going to do this problem using synthetic division. So I'm going to put 3 on the outside. It's like the opposite sign of this. And then the coefficients are 2, 4, and negative 10. So I'm going to put those at the top. When you do synthetic, you first start by dropping this first number underneath the line, and you just write it there. So you just drop it down and put 2. Then you multiply 2 times 3, and that's 6. And you write that here. Then you add down the column, and you get 10. And then you repeat. You multiply that times 3, which is 30, and then you add, which is 20. So when you do synthetic division, you add. When you do long division, you subtract. So it's kind of the opposite. Now, these values here have a meaning for your division. These tell you the coefficients of the quotient polynomial, and this one is the remainder. So when you do synthetic division, the degree of the polynomial will always go down by 1. So it started off as x squared. That means that this will be just x. So when we write our answer, it's going to be 2x plus 10 from this 2 and this 10, plus the remainder, which is 20, divided by the divisor, x minus 3. So as I mentioned this thing earlier called placeholder. A placeholder is when you add a term of the polynomial with 0 as its coefficient. And they're required if you're missing any terms. So for example, in this polynomial, it has something to the 4th power, but it's missing something to the 3rd power. And then it has the 2nd power, it has the 1st power, but it doesn't have the constant term. So if I were to write this with placeholders, it would look like this. I added 0x to the 3rd for the x to the 3rd that was missing, and I added a 0 at the end for the constant that was missing. It is required to put placeholders when you do synthetic division. You have to put the missing zeros. But it's not required in long division. It's just kind of helpful to organize yourself and to line up like terms. But it is optional there. Okay, so synthetic, it's required. Long division, it's recommended. So go ahead and pause the video and try to divide these. I would try to use synthetic when possible, and then come back and check your answer in a minute. So on this one, you can use synthetic because you're dividing by something of that form, x minus a. In this case, it's x plus 3, so we want to use the opposite sign, so negative 3. And our coefficients are 2, 1, negative 8, and we're missing the constant, so you have to put a 0 at the end. Okay, do your process of synthetic. Drop down and multiply and add, multiply and add, multiply and add. Remember that these values give the coefficient of the quotient, which is like the answer, and the last one is the remainder. We started off this time to the 3rd power, so the degree goes down by 1, so this is going to be to the second power, or squared. So this is 2x squared minus 5x plus 7, and this is your remainder. So you do plus negative 21 over your divisor, x plus 3. This problem, you had to use long division because you were dividing by something where the x had an exponent. When you do long division, you think, what times x squared will make 3x to the 4th? So that would be 3x squared. It's optional, I just like to line it up with the other x squared here. Now you're going to distribute this 3x squared with all three of these and write them under here. So when you multiply, you get this. And then remember that you're going to subtract. So be very careful with your signs. This is negative 5x to the 3rd minus negative 9x to the 3rd. So that comes out to positive 4x to the 3rd. 0 minus negative 15, negative 15. Now you always want the number of terms here to line up with the same number of terms here. So drop down the 4x and repeat that process. What times x squared makes 4x to the 3rd? So that would be 4x, multiply, write that under here, and then subtract. Again, you want the same number of terms, so you want to drop down the negative 6 and repeat the process. What times x squared makes negative 3x squared? So that's negative 3. And you distribute, you write them all under here, and you subtract. This is my remainder. There aren't any other terms. I can't keep going. And the degree of this is smaller than this one, so you can't multiply by anything else. I forgot to mention at the very beginning, I did choose to add a 0x squared as a placeholder, and it helped me line up everything correctly. So when you write your answer, this is your quotient plus the remainder divided by the divisor.